Greetings, my fellow descendants. It's your boy right here, K Pro, and today, guys, we're going to be doing a very interesting field in the branch of physical science, grade 12, which is called organic chemistry or organic molecules. That's what you guys call it at your schools, right, guys? So that's what I'll be showing you today. So let me select a brush. Okay, guys, I need you to take a pen and a paper, right, or a book, and start taking down notes, because whatever I'll be saying here will be crucial to you understanding this whole thing. And in this video, I will be introducing the topic, but I'll not be explaining the whole topic, as I realize that if I explain the whole topic into depth, the video will be too long and boring. Understand what I'm saying? So just to keep our usual duration within the limits of 1 hour, I'm going to introduce the topic, and then I'll drop another video where I'll be going into depth in terms of like IUPAC naming and so forth. And then the other one, the third video, which is part 3, where I'll be going deeper into the forces, and then addition, elimination, and substitution reactions, right? So today I'll just be doing an introduction on the organic chemistry. We used to call it that, but you can also call it organic molecules, right? That's organic chemistry, right, guys? So what is happening here is, now we have to first understand what do they mean when they're talking about organic chemistry. What are we dealing with here? All right, guys, you guys are used to me doing such mistakes, so it should not be a problem. So right, so the first thing that you have to know is that organic chemistry is a branch in chemistry. The first thing you have to know that it's chemistry, right? It's a branch in chemistry where what happens? It's a branch in chemistry that deals with organic molecules. Hence, I said you can just call it organic molecules, right? So here we will be dealing with organic molecules, right, guys? I hope you're noting down everything I'm saying, right? Now, the question is, what are organic molecules, right? So remember, we are trying to dissect this topic so that we can understand what is going on. There is absolutely no way you can start with the IUPAC naming and doing all those kind of things if you don't understand the background of the topic and how the topic comes about and what is what and what is what. I don't understand someone who will just go into a topic without understanding what topic they are dealing with. You are setting yourself for a failure. And if you want a physical science distinction and you want to get good marks in your chemistry paper, which is paper 2, this is worth 50 marks, right? 48 to 50 marks in most cases. So you'll have to know what is happening. So now they will never ask you what are organic molecules, what are organic, but I'm going to explain to you what those are so that you can understand the topic better into depth, so that when you deal with the questions that they're going to give you, it's going to be much more easier. So now the question is, what are organic molecules that we're talking about, right? What are these organic molecules? Molecules, right? That's the question. Now, organic molecules, guys, right? These are molecules, right, that contain a carbon, right? These are molecules. Let me not fudge. These are molecules. I'm sorry about that. I tried writing it better, but I can't. Molecules that, what's happening? Contain a carbon, guys. Okay, so any molecule that has a carbon with it, we can call it an organic molecule. Okay, so that's how easy this thing is, right, guys? So let's go further down. Right, so now as we dissecting this thing, why do we have to study organic molecules or organic chemistry? What is so important about this organic molecules and stuff, right? First thing we are told is that they contain a carbon, right? Now you're asking yourself, why do we have to learn this thing just because it contains a carbon? Why don't we learn about everything else? Why don't we learn about things that contain oxygens only? All right, now here's the key point about this topic, guys. The reason why they want us to learn this thing is because a carbon, please make sure that you're noting down, is spatial. A carbon is spatial slash unique, right? You can say it's spatial or it's unique, right? It's not like the other elements that you find in a periodic table. Why? Now we're going to dissect this in this way, right? So first thing you have to know about a carbon is that it has 4 valence electrons. Do you remember what are valence electrons? Yes, it has 4 valence electrons, right? Now this is a key point, guys. Please highlight this if you're using highlighters wherever you are. It has 4 valence electrons, right? So this is a unique property, right? And then what else do we know about a carbon? Another thing about it is that it can bond. It can bond with any other atom. Okay, guys, it can bond with any other atom. It can bond with any atom. Any atom. Please highlight the word any. Any atom. Carbon can bond with any other atom. That's what makes it special. Okay, and then last but not least would be the fact that carbon is found in everything. You know, carbon is found in everything. Hence I said carbon can bond with any atom. It means that it's also found in everything. You, as a human being, you have carbon within you. That's why we have something called carbon dioxide. Carbon is also responsible for photosynthesis, right? Where the plants will absorb the carbon dioxide and give off oxygen. And then we also have it within fossil fuels, right? Remember fossil fuels, you find this in life science, where and all those kind of things, right? So carbon is very much important because we find it everywhere. Everything has carbon, right? So carbon is a very special, it's a very special element, if I can say. It's very unique, right? That's why they want us to learn about organic molecules, because organic molecules are molecules that have a carbon. And why do we have to learn about this carbon in particular? Is because this carbon is very special and unique because it has 4 valence electrons. It can bond with any other atom, and it's found in everything. So which means if this thing can be found in everything, we have to know what makes it so special. Hence, we are learning about organic chemistry. Now, that's just the background of everything. They will never ask you about the properties of a carbon, guys. I'm just explaining this so that you guys can have a broader picture. You understand? It's very nice to understand a topic based on building blocks, on the monomers of it. So how I explain a topic is that I'll give you the monomers of it. When I'm saying monomers, I mean the building blocks. Basically, what I'm saying is if I build it bit by bit until it becomes a whole house, the topic will stay in your brain, guys. Do you understand what I'm saying? So that's how I teach, right? I prefer giving you every single detail about the whole topic so that when you start attempting questions, you know something. You've already built a house, right? Good. So now let's move on. Let's move on. Now we're going to branch into hydrocarbons, okay, guys? Now that we know how a carbon is special and everything like that, we are told now. We are told we have something called a hydrocarbon. Please allow me to rub these off, alright, guys? This might take time, so let me just increase the size so that it can be much more efficient and faster. Okay, guys. And then I'll take back the size later on. Haha. Right, guys. Okay, guys. So now, why is it so fat? Okay, guys. So now, I'm going to try and be as fast as possible, but informative as well. All right, guys. Cool stuff. Is it better now? Good. So guys, one thing now that I have to teach you guys is that we are being introduced to something called a hydrocarbon. Now, in this chapter, we have to familiarize ourselves with something called a hydrocarbon. Now, what is a hydrocarbon? Is that a hydrocarbon is, should I say, a compound? Yes, right? It's a compound that has, okay, let's look at this first. What is a hydro? The word hydro, where does it come from, basically? You can tell that this comes from hydrogen, right? It comes from hydrogen. And carbon, you know what is a carbon, right? So we know that this is a carbon, right? So what is a hydrocarbon, guys? It's the combination of these two. right? It's a compound that has hydrogen and a carbon, where the hydrogen and the carbon are bonding, all right? So this is a hydrocarbon. It's very important for you to know this because we are going to be dealing with hydrocarbons in this topic, guys, right? So that is what a hydrocarbon is. They will never ask you what is a hydrocarbon, guys. They will never. But because I want to build you up, please understand what is a hydrocarbon, right, guys? Good. Now we can go into the real thing. Now that we know what is happening, we can go into the real thing and understand what is going on. Right, guys? Oh, okay. Cool stuff. Just give me a sec for rubbing off this thing over there. Alright. Now we're going to go into the real thing, guys, right? Please pay attention. Please do pay attention. And make sure that you listen attentively. Right, guys? We are going to have something called a homologous series, guys, right? Now, any term that I'm going to say here, it's not important for you to define it the way I'm defining it because you have an examination guideline, all right? So it's very important that, as I always say in my videos, define everything using the examination guideline. Cram that examination guideline, like know it within, like with your heart and everything, right? So you don't have to know the definition of these things, right? But what I'm going to do right now is that now I am going to draw a table. Most of you have this table in your examination guidelines. I'm going to dissect this table and explain it to you, but I'm going to draw it in my own way, in my own informative way. Ne? But before I do that, I want to explain to you what is a saturated compound, right? And I want to explain to you what is an unsaturated compound. Okay, guys. A saturated compound, it's compounds that only have single bonds, right? Only have a single bond, right? And an unsaturated compound, it's these that have a double and triple bond. You are most likely to find a question like this, guys, so they might ask you to define this. Okay, guys, so this is what I wanted to teach you guys, right? A saturated compound, if they ask you anything about this, it's usually having a single bond, mostly alkanes, and then unsaturated compound is mostly alkynes and alkenes because they have double and triple bonds, right? Not important as much, but it's important if you want to get good marks because they might ask this for 2 marks, right? So it's important for you to define that, right? We are going to move now to the raw stuff, the table, guys, right? I'm going to draw the table now. Right, guys, please be patient with me as I draw the table, and I'm gonna draw the table hand in hand with you, so please pay careful attention. I hope your book, your pen, it's there and you are ready to take down whatever I'm going to say right here. Okay, guys, now we have what we call alkanes. Remember, this is just an introduction, right? What are alkanes, guys? This are now compounds that have a single bond in between them, right? So the first thing that I would like us to do, right, I want us to group this into a table, right? We have to know the homologous series, guys, right? Now a homologous series, I'm not going to define it according to your examination guideline, but I believe that it's organic compounds that can be defined by the same general formula, right? Good. Now, what will happen is I want us to name all the homologous series that we know, right? All these that we know. We know that we have an alkane. We have an alkene. Let's first name them, guys. We have an alkyne, right? What else do we have? We have a haloalkane, but some people call it an alkyl halide. but I always call it a haloalkane so that I can remember, right? A haloalkane. We have alcohols, right? This one everyone is gonna remember it because vele niyatawa. And then we have the aldehydes and ketones. Okay, guys, aldehydes and ketones. Okay, guys, we have the carboxylic acids, and we have the esters. Okay, guys. Okay, guys, I hope you're on the same page and everyone knows what these are, right? So now we are going to draw a table. Let me start by drawing a line. I don't want to make it straight because I know it's going to be skewed regardless. Right. Now, guys, do we agree, all of us, that everything that I've said from 1 to 8, that's what we call a homologous series, guys, right? These names, the names of all these compounds are called a homologous series, guys, right? Please do remember that this is a homologous series. Okay, guys, they can be defined. Anything that is an alkane can be defined by the same general formula, right? So these are different homologous series, okay, guys? So alkanes, it's a homologous series. Alkene, homologous series, okay, guys? Do not be confused by when they say give the homologous series of this thing, and you start thinking about other things, guys. A homologous series is everything that I've mentioned here, right? Now, guys, a functional group, right? A functional group. I am not going to define it. You can check your examination guideline, right? But I know what it is. Don't get it twisted. Oh my God. I know what it is. Right? So, a functional... Let me see where this is. A functional... Right there. Functional group. Right. Then what do? I can draw another line there. And now we're going to deal with the molecular formula. The molecular... What did I miss that now? I keep on missing an L. I don't know why, guys. I'm sorry. A molecular formula. I believe it's because of where I'm writing. It's at the top of this thing. So it's confused. Alright, guys. So now that we know what a homologous series is, guys. Now we have 8 homologous series, as you can see there. You don't have to cram this because they are always there. We have alkanes, alkenes, alkynes, haloalkanes, alcohol, aldehydes, ketones, carboxylic acids, and esters. These are homologous series, guys, right? Then now we have to know what is the functional group of an alkane. Now, this is what I usually do. This table has helped me out a lot. Right. Right, guys. So what an alkane, what do we know about an alkane? It's those compounds that have what? They have a single bond. So that single bond is our functional group. That's how it functions. It has single bonds. That's how we can define it, right? So that's the functional group of an alkane. It has single bonds. Do not cram these things. Look at an alkane and look at its structure and its properties. You can tell that it has a single bond, right? It's a saturated compound, right? And then we look at the alkene. Now, let's see. The alkene, what do you know about alkenes, guys? Alkenes have a double bond, right? So since they have a double bond, that is the functional group. That's how it functions with a double bond. That's its property. Okay, guys? It has a double bond, right? Or bonds, yes. We have alkynes. Now, alkynes, guys, have a triple bond. Now, the first 3, yeah, they're very easy, guys. There's no way you can forget that an alkane is a single bond, alkene double bond, alkyne triple bond, okay? So now we have that this is a triple bonds. I hope it makes sense now, how I'm actually giving you all these functional groups of these things, right? Now we go to haloalkane, guys. What are haloalkanes? Someone might ask you that. Haloalkanes, the word halo comes from halogens. Now, if you can go back to your grade 10 and you look at your periodic table, we have halogens. My teacher used to say to me, those are stable elements. Basically, these elements, they do not need electrons from other, I'm not sure if I'm mistaken or what, but that's what they used to tell me, that, okay, if you see something called halogen, just know that it does not need to react or whatever to gain electrons or lose electrons. It's stable. I'm not sure if I'm mistaken or not, because I did grade 10 a long time ago, right? But the fact is, halogens, you find them in the periodic table, right? And now what they're saying to us is that it's a haloalkane, which means it's an alkane, which means it has single bonds, but now it is a halogen, right? So we are not going to say it is a single bond, but we're going to say it is a 4-mile group, right? From here, we're going to work with groups, guys, okay? It is a 4-mile group. Where the name comes from, I don't know. 4-mile, guys. This is a Y, okay? 4-mile group. Where the name comes from, I don't know. I was taught as well, right? About the 4-mile group, right? So haloalkanes have a 4-mile group, right? This is basically a combination of a halogen and an alkane. Basically, it's a halogen that is reacting, but in the form of single bonds. Do you understand what I'm saying? All right, guys. And then we have alcohol. Guys, alcohol is very easy, and I don't think there's a grade 12 learner who's going to have a problem with alcohol, because you guys drink a lot, and that's a fact. So, alcohol, guys, it has OH. OH is what in science you call it a hydroxyl group, okay? Hydroxyl group, right? Now, guys, what I'm saying here with these functional groups is going to be important when I start explaining the structures of each and every homologous series here. So pay attention to what I'm saying. Then we have aldehydes and ketones. I'm still going to go deeper into these. What you have to know about aldehydes and ketones, guys, is that aldehydes and ketones is like a brother and a sister, right? They have the same blood, but they have different body organs, right? Simple. The same blood, same DNA, but different organs in the body, right? So, but they come from the same family, which means they share a same name, right? What is the functional group of this? It's a carbonyl group, okay? It's a carbonyl group. You are soon going to notice why we call it a carbonyl group when we go practical, right? Carboxylic acids, guys, acids. Okay, this one, it's so easy. You're just going to say it has a carboxyl group, right? It has a carboxyl group. Not a problem. And then we have esters, ne? Esters, it's a combination of the carboxyl group, pay close attention, plus the hydroxyl group, which means we are combining the carboxylic acids and alcohol to make esters, right? This is also called condensation, just to make sure that my fellow scientists do not insult me there over the comments, right? Now, we have to know the molecular formulas of everything here. Guys, you don't have to write this down, because I believe most of you guys have this in your exam guidelines, or your teachers have taught you about these, right? I'm doing this because I'm teaching those who I think do not understand this thing. So I'm studying everything all over so that I can explain it in phases, right? So the question would be, what is the molecular formula of these and stuff, right? Right. So I'm going to write these down for your sake, but what I'm going to be explaining next does not need you to know the molecular formula, right? So the molecular formula of this one is written as CnH2n plus 2. Guys, N stands for the number of carbons. Ne? N is the number of carbons. I will soon show you how this works, right? And then this one, it's CnH2n, if I'm not mistaken. Yes. And then this one, it's the opposite of alkanes. This is CnH2n minus 2, right? If I'm not mistaken. And then the ketones, okay, the haloalkanes first. All right, the haloalkanes, I believe they share properties with the first one. Should be like this though. It's very rare that they might ask for this one, but it's simply like that. It's an alkane after all. Then the hydroxyl group, guys, which is the alcohol, it's CnH2n plus 1. That's your alcohol. And then your aldehydes and your ketones, the brother and sister is CnH2n O. Guys, I said N represents the number of carbons. And don't be confused by this O. This O just basically stands for the oxygen. You'll soon understand why there's an O here, and you'll soon understand where's the alcohol, and you'll soon understand why there's what there is here, right? No problem. The carboxylic group has CnH2n plus 1 plus 1 COOH. Okay, guys. Yes, CnH2 H2n. H2n. This is H, guys. Don't get it mixed up. All right. And then what would we have by esters? Do I have one for esters? Yes. One for esters says H2n plus, what's that number now? H2n plus, okay. I see COO. Please do correct me if I'm wrong, guys. Right? Something like that for esters. Okay. Okay, guys. Now that we have this famous table of ours now, everything is going to be easier when I explain it in the next topic. So you don't have to copy this down because you have it in your examination color. And if you don't have it, you can copy this down, but it's actually irrelevant because the only important part for me, for you to know, would be, okay, everything is important here, but I believe you have an examination guideline for all these things. So not really. So let's see how we're going to navigate into the next explanation. All right. I hope everything made sense, I believe. All right. Okay, guys. So now we're going to go into depth. So I'm going to be explaining the properties of each and every homologous series so that you can understand it before you start naming them and drawing them. Okay, guys? Before we can start with the drawing and the naming and stuff, that will be another tutorial. For now, I'm going to explain each one of them in depth. Right. This is going to be fun now. Right. Good stuff. Alright, good stuff. Okay, guys. So now let's talk about alkanes. Right? Now I told you that alkanes have single bonds. This is very easy, right? They have single bonds, right? And what do we know about alkanes? Since they have single bonds, it means that they are saturated, right? They are saturated, right? Good. Now that we know all these, what's going to happen now is, how do we identify an alkane? Guys, this is very, very much easy. I don't think anyone would get this wrong. So let me draw an alkane. This is just an example, okay? I'm not teaching you how to name, but I'm just teaching you identification, right? Right. Now you'll understand why I was saying everything I was saying in the previous slide. Okay, guys. Do you notice that there is a reaction between the hydrogen atoms and the carbon atoms, guys? So this is what we call a hydrocarbon, right? Can you see why I explained hydrocarbon earlier on? Because that's what we're dealing with here. So this is what we call a hydrocarbon. You'll never be asked this, but just for your knowledge, this is what we call a hydrocarbon. Okay, guys? Right. So Your question might be now, what is this? This is an alkane, guys. How do we see that this is an alkane? There is only single bonds in between. Can you see that? Single bonds, single bonds, single bonds, all the way throughout, right? Now that's how we know that these are alkanes, because there's only single bonds in between, right? So this is an alkane, right? And I already gave you the functional group that it's single bonds. That's what represents its properties. Once I say mention an alkane, single bonds, right? It's like this, guys, right? So let's talk about same names, right? If your name is Kenneth Nkosi, right? And I'm saying describe the Nkosi people, right? Obviously, there's that characteristic that everyone in the clan has, right? Maybe you guys are musicians throughout the whole family. You guys are sports people. Do you understand? You guys are defined by your properties. Do you understand? If you guys are royal blood, then you'll say, oh, this one is a royal blood. Do you understand what I'm saying? So it's the same thing. It's the same thing, guys. It's basically, I used to say to my learners, a functional group is like a surname, right? It's like a surname. Identification, DNA. Do you understand what I'm saying? Right. So now we know what is an alkane. Now I'm going to squeeze something in. A halo alkane. A halo alkane. I told you that this means a halogen, right? Now, how do you know that I have a haloalkane? Simple, guys. You see where this is? I'll just come here and put Br. Now, this is a haloalkane, guys. Why? Because where there was my hydrogen, I now have bromine, right? Go to your periodic table and check the position of bromine. Which group does it fall under? It falls under the halogens, right? Hence, we have that. The single bonds are still there, guys. Don't get it twisted. The single bonds are still there. The difference is now we have single bonds. They're still there, but now we have a visitor, and this visitor is called a haloalkane, a halogen, right? Hence, we have a haloalkane, right? We have a halogen right there, as you can see there. So the difference between this and this is that this one only has hydrogens and single bonds, and on this one has a visitor, right? Once you see BRF, oh, there could be fluorine as well, right? I don't know what else. There's a lot of them. Once you see those, just know that it's a haloalkane, guys. Single bonds are always there. The bond does not change. What changes is the visitor, right? We remove the hydrogen and we put what? Our bromine, right? Later on the third part of this tutorial, I will be showing you guys how the substitution of hydrogens and all these things work to create useful substances within the science branch. Okay, guys. Now I've explained alkanes. I'm going to try and be quick, and I'm going to explain alkenes. Alkenes, guys. Alkenes. Guys, alkenes, I told you that they have a double bond, right? Now, how do you know that something has a double bond? This is so easy. Very easy. I believe you have something like this in your examination guideline. If you don't, it's fine. But this is basically your alkene, right? It has double bonds. Can you see that? It is double bond, and this is our functional group, right? This is our functional group, right? It has a double bond, simple as ABC, right? Simple as ABC. Now we have what we call alkynes, right? Now, guys, when we're dealing with alkynes, right? What do you know about alkynes, guys, is now alkynes have a triple bond. 1, 2, 3. A triple bond, right? These are alkynes, right? So let me try and attach an H there and an H there. Now, there's a silly mistake that I want you to take note of here. Ne? Do you remember that we said a carbon has 4 valence electrons, right? the fact that carbon has 4 valence electrons, it means that it can only take 4 bonds. Remember that. It has only 4 valence electrons, which means it can only take 4 bonds, right? So, yeah, each and every carbon can only have a maximum of 4 bonds. Let's count. Let's count and make sure that we are on the right track, right? Look at this carbon, right? How many bonds are there? 1, 2, 3, 4. Look at this carbon. How many bonds are there? 1, 2, 3, 4, right? If I were to put bonds here and here, this is completely wrong, ne? Because it only has 4 valence electrons. Where will the other electrons come from to create other bonds? Okay, guys, so a carbon has 4 valence electrons. That's why I highlighted this point earlier on when I was talking about carbon's properties of a carbon, because a carbon only has 4 valence electrons, meaning that it can only take 4 bonds. Every carbon takes in 4 bonds. I'm emphasizing this because people like overloading the carbon, and once you overload the carbon, your structure is wrong, right? So you have to know, right? Especially when it comes to alkynes, they like asking questions that are based on this because they know that you are going to overload the carbon and get 0, right? So can you see that once you have a triple bond, there is no way you can put hydrogen bonds on top of these, right? Because you'll be overloading, right? I believe I'm clear on that one. That's why I had to raise my voice, because you guys will have to understand that part, right? Remember, the aim is a distinction for everyone. And if you believe in yourself, you can get that. Just avoid doing silly mistakes, guys, by all costs. All right, now I've explained one of the most easiest things you can ever find within the organic chemistry. Everything is easier, but this is the most easiest things that you can ever find. Now, let's deal with the alcohol. Now, I know you guys like this one very much. So this one is very interesting now, right? Now, the alcohol, I told you guys that it has a hydroxyl group. The functional group is a hydroxyl, right? What does the hydroxyl stand for? It stands for OH. Ne? What does it mean? Right, remember when I drew an alkane earlier on, I said C, and what did I say? Something like this. I drew something like this, right? Now, because this thing is an alcohol, it will have a reaction with OH. Simple. Simple as APC, guys. Simple as APC. An alcohol will be, it's basically now this compound that has a hydroxyl group within it, right? Which means you take your alkane and then you add OH there. Can you see? And this is what we call an alcohol. Ne? Does it make sense, guys? This is an alcohol, right? It has OH. Anything that has OH within it, only OH, take note, only OH, it's called an alcohol. Now, you guys have a problem of not understanding something. They might say there is what we call a primary alcohol, a secondary alcohol, and a tertiary alcohol. Now, when they say primary, they don't mean that it's the alcohol that is drink whatever. It's not the alcohol that is consumed by primary school children. No. Now, primary alcohol, I'm going to try and explain them here. A primary alcohol. How do we spot a primary alcohol? Simple. This is a primary alcohol. How do we know that? Now take note. The carbon that is attached to the hydroxyl group, the OH, is bonded with one other carbon. Ne? Does it make sense, guys? I hope it does make sense to whoever is listening to this tutorial, right? Let's think about it this way, right? We have someone, I'm going to try and make an example. We have someone who's holding a baby and they are crossing the road, right? They are crossing the road. They are crossing the road, right? This baby is the OH, the hydroxyl group. And now this is the carbon, right? If this older person is also holding hands with his wife, one wife, right? This is what we call a primary alcohol. I hope it makes sense, guys, right? We have a man who has his child in his hand and they are crossing that road right there, right? If this man is only holding one wife, then we call it a primary alcohol. But if he has two wives that are also holding each other, this man is in a polygamous marriage and they're all holding each other. These are females, by the way. What does that mean now? We call that a secondary. Why? Because this man who is the carbon is attached to two other carbons, two other wives. So we call it a secondary alcohol. Right. Now, if he decides that he has three wives now, if he has three wives, this carbon, the man of the house, who is carrying his son there, is also holding hands with three other women, three other carbons, which means now we say it's called a tertiary alcohol. I hope it makes sense, right? So what do you know about a primary alcohol? Is that the carbon that is attached to the OH is also attached to one other carbon, one, right? Secondary, what do you know? The carbon that is attached to the OH is attached to two other carbons, right? Tertiary, what do you know? The carbon is attached to three other carbons. I told you there is a man here and his son, and they are working. This son, we consider him as the OH, and this man is the C, the leader of the family. And now what happens? He has his wife there. If he's only holding hands with one wife, we say it's a primary alcohol. If he's only holding hands with two other wives, we call it what? A secondary alcohol. If he has three wives and he's holding their hands at the same time, it's a tertiary alcohol. Now let's put this into practical example. We agree that this is a primary alcohol. Why? Because this C is only attached to one carbon atom, right? Good. Let's see if we can get a secondary alcohol using proper chemistry. Right, guys. I didn't want to take time with this, but seems like I'll have to. Alright. So let's look at it this way, guys, right? Good. Just find a perfect example for this. Right. I want you guys to look at this now. This is H, H, H. Okay, guys. Can you see that this carbon is attached to that, right? That's the father. And this is the son, right? How many other carbons are attached to this thing? There's three other carbons. There's two other carbons, my bad. Two other carbons. 1, 2. The fact that there's two, that means it's a secondary alcohol. This man only has two wives, right? This is the man of the house. We want to know how many wives does he have. He has two wives. That means it's a secondary alcohol. But if there was three other carbons, yeah, it means that it was going to be a tertiary. Please drop comments if you don't understand. And please don't forget to subscribe. Now we can move on to something else. Another important chapter in this whole thing that I'm discussing today that most people get wrong is called the carbonyl group. Basically the aldehydes and our ketones. Now I'm going to explain these thoroughly. They are very easy. Just that people have misconceptions about them. People have misconceptions about them, but we're going to deal with those just now. Just want to scratch this off, right? We're going to try and to get rid of this, right? Okay, guys. We're going to handle this one now. This is one thing that they're going to ask you. They always ask this question and people fail to understand. Hence, I'm going deeper into everything and I'm dissecting so that you can understand what is going on. This is a question that they're going to ask you. So I'm going to explain this one thoroughly because they always ask this one because they know that students fail to understand what is going on here, right? So I'm going to explain this one thoroughly. Now we have what we call the aldehydes and ketones. Guys, please take note of something there. Aldehydes and ketones, they are siblings, right? Same father, same mother, same DNA. The difference is that the other one is a male, the other one is a female. Simple. Please do not say this when you're writing your paper. This is for your own understanding, right? They are from the same family, which means they have the same surname. What is our surname, by the way? Is the functional group. So they have the same functional group, the same surname. And then what else do they have? The same general formula, right? Same general formula or molecular formula. Okay, guys. Same general formula. They have everything that is common here, right? But now, what is the difference between the two? Now let's see. The aldehyde, guys, simple. The aldehyde. Okay, before I can do that, I have to first explain what is happening here first. Aldehydes and ketones have a functional group called a carbonyl group, right? A carbonyl group, which means now this is represented by something like this. A carbonyl group is a combination, or it's a bond of a carbon atom, a double bonded with an oxygen. So it's when a double bonded oxygen and whatever is bonded to the carbon. I don't know how to put this in English, guys, okay? It's when oxygen is double bonded to the carbon atom, right? As you can see, there's a double bond and there's oxygen and there's a carbon. That's why we call it a carbonyl group. Okay, guys, so this is what we are looking at when we're talking about a carbonyl group. This works for both the ketones and the aldehyde, right, guys? They are siblings. This is their same, this is their DNA structure, right? So carbonyl group is basically the bonding, the double bonding of carbon and oxygen. Oxygen is always double bonded in this case, ne? Okay, guys. So now I can explain what I wanted to explain to you guys that kills you. Now, what you have to know about this is that the difference between these two, one is a female, one is a male. Why do I say so? An aldehyde, guys, right? It's something like this. 1, 2, 3, 4. Let me put the fourth one here. All right. Let me draw a line. There is a ketone. A ketone is something like this. Let me stop right there and say that, and then say continue, and age, and then yeah. Okay, guys, now let me see if it makes sense. I want to go back to my own things. Okay, guys. Okay. Right. Okay, guys. What do you notice about this is that the carbonyl group, this thing, the carbonyl group, is found at the end. Simple. This is how you identify an aldehyde. And this side, this carbonyl group, is found at or in the middle. Let me say in the middle. In the middle. In the middle. Right? Let me say or at the beginning. Okay, guys? So now listen to me very carefully. Aldehydes, you will find this carbonyl group at the end or at the beginning. Can you see that this thing is at the end? Yes. And now, what about the ketones? When it comes to the ketones, you'll always find the ketones in the middle. How do you know that it's in the middle? It's surrounded by other carbons, right? It has bodyguards, right? It has bodyguards. Does this one have bodyguards? Not really, because there is only a hydrogen atom this side and a carbon atom that side, so it doesn't have bodyguards. So can you see that this one is surrounded by other, right? It's safe. It's in the middle. It's safe right there, right? I hope you understand that, right? Cool. Now we're going to move into understanding carboxylic acids and then I think esters as well. Okay. All right. So I want you guys to pay careful attention to what I'm going to say next. All right. Right. All right. Cool, guys. No problem. Just give me a sec. Just to update this. It's fine. Right, guys. So now I'll have to explain to you what is a carboxylic acid. Now this is very important, guys. Oh, I didn't change the color. A carboxylic acid. Now I want you to note something there. A carboxylic acid, I told you that the functional group is a carboxyl group, right? A carboxyl group. Now I'm going to show you how this carboxyl group came about. To show you that how easy chemistry is. A carboxylic acid, guys, it's the mixture of a carbonyl group, right, plus a hydroxyl group. What is a hydroxyl group, guys? That's your alcohol. What is a carbonyl group? That's your aldehydes and your ketones. Now, how do they come up with this carboxylic? We can see that we have carbo there and we have hydro there, right? So what they decided to do is to take the first word and bring it down here and erase that. And they decided to do what? To take this last word, which is what we call a suffix in English, and bring it down. And they came up with a name called the carboxylic, right, acid, right? So they decided to take the prefix of the carbonyl group and the suffix of the hydroxyl and bring them together. Then they came up with this name. So what I'm going to tell you is, even if you forget that this is a carboxylic group, you are allowed to say it's a carbonyl plus hydroxyl group. You are going to be given marks because this is basically a formation of a new word using the prefix and the suffix. Okay, guys. So this is basically a mixture of the carbonyl group and the hydroxyl group. They mixed this together. They said this and they mixed this together. This is what they're telling us. There is nothing more, nothing less. Okay, guys. It's a mixture of this and this together, right? So that's what is happening here, right? So I'm going to try and draw a carboxylic acid, right? And just show you that it's basically just a mixture of OH and the carbonyl group, which is C double bonded to O, right, guys? So let me see if I can draw one quickly. C O H. Then I can just double bond this one. Then H. Then H. Then H. Guys. So that's how easy it is, right? Take note of something that I taught earlier on. Can you see that there's a double bond here, right? It means that, can you see that my carbon is not overloaded? If you can count the number of carbons here, I can't put a hydrogen carbon here. A hydrogen bond, I'm sorry, here. Why? Because I already have 1, 2, 3, 4. So if I put 5 here, this thing is putrid. It's wrong, right? So I hope you still understand that. So this is what is happening there, right? Let me remove that. So this is a carboxylic acid, guys. Why? Because it has a mixture of the carbonyl group, aldehydes or ketones, and then it has the mixture of the hydroxyl group from the alcohol. There is your alcohol, and there is your carbonyl group. Can you see that? Great stuff. Very easy, guys. Now we're going to go into esterification. Now, esterification is basically still the same thing that is happening here. But now, here it's a mixture of the carboxylic acid and the hydroxyl group. This is where it gets tricky now because the carboxylic acid has a hydroxyl group already. And now you have to mix it with the hydroxyl group even further. So let's look at this properly. Esterification, which is usually called condensation, guys. Ne? Why? Because there is water that is released. Yeah. Okay, guys. So this is what is going to happen. In order for me to do esterification, I have to take note of something. The functional group of this, as I told you earlier on, it's going to be your carboxylic acid plus what? Let me check. It's your carboxylic acid plus your hydroxyl group. Your hydroxyl group. Okay, guys. Now, the combination of these two, let's put it into practical form and see what's going to happen, right? Now, I'm going to try and create an alcohol first. Yeah? Let's write down an alcohol. Let's put together an alcohol. Right. An alcohol will be something like this. Let me see. Yeah, something like this is an alcohol. OH. Simple, ne? H there. Right? This is an alcohol. hydroxyl group. There is the hydroxyl group right there, right? Hydroxyl group, as you can see, right? We are going to add this hydroxyl group with what? The carboxylic acid. I can always draw any type of carboxylic acid. Now remember, a carboxylic acid usually has what? Let me show you something. It has a combination of the carbonyl group and it has a combination of the alcohol as well, right? And that's going to be OCCH, okay? The bonds are enough here. Great stuff. And then what will happen after these happen? This is a carboxylic acid. Can you see? This is a carboxylic acid. Carboxylic acid. Carboxyl acid. Right, guys. Now, if you forget that this is a carboxylic acid, just remember that there must be a carbonyl and a hydroxyl group. What do these give me? This will be equals to, in order for this thing to happen, I have to have the presence of a catalyst. I know you know this from your equilibrium and so forth. A catalyst, right? Which is an acid, so that this process can happen, right? And then what will I have after? I must have water as a result, right? That's the first thing you should know. How am I going to create this water? How am I going to create water, guys? Let me show you how I'm going to create water. Do you agree with me that I have a OH here? Yes, I have OH there. So I'm just going to say I'm going to steal this OH and I'm going to steal one H from this one, and then I combine them and then they're going to give me my H2O, right? I stole OH here and I stole one H here so that I can create water, right? Great. Remember, I'm using a catalyst as well. Whatever is remaining, I write it exactly as it is this side. What is remaining? I'm going to try and write it, but it's not going to be as efficient. So, you know, there's an H there. This is what is remaining. I remember I stole the H, so the H is no longer there, right? I stole the H is no longer there. What do I have now? Plus H, so I'll have something like H, right? I believe so. What else do I have there? I'll have something like a C that will bond it to O, and that's it. So can you see how easy this thing is, guys? Basically, I stole this, I stole that, and then I stole this OH and I got rid of it and I created water, and then whatever was remaining I combined it together, and this is what we call esterification. Esterification is very much important when we're dealing with cosmetics. My teacher used to say perfumes as well, smells, fragrances, and all those kind of things. That's what they use condensation or esterification for, right, guys? And that will be the end of this lesson. Now, please, guys, do me a favor, guys, right? Please hit the subscribe button if you like what you're saying or whatever I am teaching. I'd really appreciate that. So please, guys, please just come over there and just subscribe. Okay, guys, we are also on Facebook, SciMasterZA, guys, right? Please subscribe. Please do hit me up on the comments with something that you don't understand or show gratitude or anything. Anything is fine, guys, right? On the next tutorial, however, I will be going deeper into IUPAC naming, condensed structural formula, and all those kind of things, right? And getting deeper into the the molecular formulas. What I was doing here, I was explaining the homologous series and their relationship with the functional group. Next, I'll be doing the molecular formulas, the structural formulas, the condensed structural formulas. Then I'll also be doing IUPAC naming, right? Then I'll be having a third part tutorial for this topic where I will now be teaching you guys something about addition, substitution, and elimination reactions, combustion, and everything like that, to wrap up the whole topic, right? So far, what we have done, just go through your notes and check out. Make sure that you understand everything I've taught so far, so that when you go deeper into this, you don't get left behind, okay? Once you get left behind here, there is no way that you're going to understand organic chemistry. From me, your boy, KPro ATM, I'm out. Don't forget to subscribe. Thank you very much for your